Hi dear friends, welcome back to our channel Anvinay Kumar Basics of Physics. Dear friends, this is the third video regarding the previous year questions of NEET from the chapter Units and Measurement. So I was already uploaded part 1 and part 2 and this is the part 3. I will share the playlist of the particular videos in the end of this video. Okay, it will be given in the end cards. Without late, going to the topic. The question is here: if force F, acceleration A and time t are chosen as the fundamental physical quantities, find the dimension of energy. So we have to find the dimensions of energy or dimension formula of energy by taking the force, acceleration and time t as fundamental quantities. Clear? And it was given in the NEET exam 2021 and some options are here. So now we have to solve that one. Some options are given. Option A is F A inverse 1 t, F A t, F A t inverse t square, F A t inverse 1. These are the options. Now we have to solve it. So what was given, we have to find out the dimension formula of energy. So according to the principle of homogeneity and dimensional equations, we have to solve this one. The energy is directly proportional to the force and acceleration and time t. So to find out the dimensions, initially we have to take them as A, B and C. Now we are going to use the dimensional formulas. For energy, what is the dimension formula? M L square T inverse 2. Clear? For what is A? A is the acceleration. L T inverse 2. And what is T? Time. Dimension formula is what? T. Now we have to substitute them. Simply here I am going to write M L square T inverse 2 is equals to some constant into F is what? Force. M L T inverse 2. Clear? This is for force. F is what? M L T inverse 2. It is the dimension of force. And whole power of A. And what is A? Acceleration. L T inverse 2 whole power of B. And what is T? T is the time. Clear? So T whole power of C. According to the principle of homogeneity, the physical quantities which are in an equation that should be having the same dimensions on LHS and RHS. That's why here first we have to compare the according to principle of homogeneity. So what right? First we have to compare the dimensions of M. Dimensions of M on both sides. So here M power 1 is there here, and here M to the power of A, and L to the power means M is not there. Simply it is 0 and it is also 0. Then what you have? A is equals to 1. And now compare the dimensions of L on both sides. Dimensions L on both sides. Here what is there? On LHS 2 is there. On RHS A plus L to the power of B means what? It is B. Clear? So 2 is equals to A plus B. 2 is equals to A plus B. And what is the value of here? A. 2 is equals to 1 plus B, and 2 minus 1 is equals to B. 1 is equals to, here B is equals to 1. And similarly, now you can compare the dimensions of time on both sides. Then what it is here? Minus 2 is equals to minus 2A plus of minus 2B here plus C. That means what? Minus 2 is equals to minus 2A minus 2B plus C. Now we can substitute the values of A and B there. Minus 2 is equals to minus 2 into 1, 2 into 1, B also 1 plus C. So minus 2 is equals to here minus 2 and minus 2 plus c. That means what? Minus 2 is equals to minus 2 minus 2 minus 4 plus c. Then what, right? C is equals to minus 2 plus 4. That means what? C is equals to 2. So C is equals to 2. So A is equals to 1, B is equals to 1 and C is equals to 2. Now we can substitute the values of A, B, C in that equation. What we get? E is equals to F to the power of A. F to the power of A means what? 1. So means like F. And A to the power of B. So that means what? It is also 1. And now T to the power of C. C means what? 2. So T 2. So this is the dimensional formula of energy in terms of force, acceleration and time. That's why you have to check the options. Now third option is the correct one. F A T squared is the right one. C is the right answer. See the next question. It was given in the 2017. A physical quantity of the dimensions of length that can be formed out of C G E square by 4 pi epsilon naught is a physical quantity of the dimensions of length that can be expressed in terms of C, G and this one. Within the bracket C was given. C is the velocity of light, G is the universal gravitational constant and small e is the charge. Small e is the charge. Then the options are given. C square into G E square by 4 pi epsilon whole to the power of 1 by 2. And second option 1 by C square into E square by G into 4 pi epsilon naught whole to the power of 1 by 2. And 1 by C into G of E square by 4 pi epsilon naught. And D option is 1 by C square into G of E square by 4 pi epsilon 1 by whole to E square by 4 pi epsilon whole to the power of 1 by 2. So these are the options. So options are seems to be same, but lot of difference is there. Look here now once. So what is the question? We want to express the length, dimension of length in terms of C, G and this one. Here what is C? C was given velocity of light. And what is the universal gravitational constant? And what is small e? Charge. So here first thing is C. What is C? L T inverse 1. It is the dimensional formula of velocity of light. And next thing is universal gravitational constant. M inverse 1, L cube and T inverse 2. This is the dimensional formula of G. And now we have to find out the dimensional formula of this one. E square by 4 pi epsilon naught. Here according to the Coulomb's law, what we write? F is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R square. Here Q1 is the charge, Q2 also charge. Simply I am going to take like this 1 by 4 pi epsilon naught into Q1 is equals to Q2 is equals to E. Then what to write? E into E means what? E square. E square by R square. So F is equals to E square by 4 pi epsilon naught into 1 by R square. Then what to write? Here E square by 4 pi epsilon naught is equals to nothing but F into R square. F into R square. So what is here? E square by 4 pi epsilon naught is F into R square. What is F? Force. Its dimension formula is what? M L T inverse 2 and R is the distance. For that dimension formula is L. R square. L square. So then what is here? M L cube T inverse 2. So this is the dimension formula for E square by 4 pi epsilon naught. So now we are going to use this one. Here I need some space. That's why here I am going to write here the same thing. E square by 4 pi epsilon naught is what? Dimension formula M L cube T inverse 2. So in this way we will get. Okay. Now here, now we have to write the dimensions by using the dimensional equations and according to the principle of homogeneity. So that is what L is proportional to here. The first thing is what? C. C to the power of A. And next one is what? G. g to the power of b, and next is what? E square by 4 pi epsilon naught c whole to the power of c. Clear? What is L here? Length. For the dimension formula is what? L. Here, by using some constant ordered here, simply L is equals to here. We have to add one more step. Here, L is equals to some constant into c to the power of a and g to the power of b, e square by 4 pi epsilon naught whole to the power of c we can write. Okay. So now substitute the dimension formulas. L is what? Capital M, and c is what? L t inverse 1 whole to the power of a, and what is g? M inverse 1 L cube t inverse 2, and this one is what? E square by 4 pi epsilon. It is what? M L cube t inverse 2. Here we have to write m inverse 1 L cube t inverse 2 whole to the power of b, and it is now c. Clear? So now we have to compare the dimensions on both sides. According to principle of homogeneity, the physical quantity in a dimensional equation that should have same dimensions on LHS and RHS. So first you have to compare the dimensions of M. Dimensions of M. So here M is not there. That's what I write here. 0 is equals to 0 plus. Here it is what? Minus b, and this is what? M plus c. So therefore 0 is equals to minus b plus c. Equation number 1. And in the same manner, we can compare the dimensions of here L. Dimensions of L here on the both sides. Now what is L to the power of 1? 1 is equals to here a, and this is what? 3 into b, a plus 3b, and it is 3 into c plus 3c. Equation number 2 now. And now third one, we have to compare the dimensions of now t on both sides. If t is not there, 0 is equals to here minus 1 into a, minus 2 into b, minus 2b, and minus 2 into c, minus 2c. Equation number 3. So after that, by solving the 1, 2, 3, we will get the values of a, b, c, like that. So for that purpose, here we have to use this space like this. Once again, so first I am going to add the 2 and 3. Add the 2 and 3. What is 1 is equals to here a plus 3b plus 3c, and 0 is equals to minus a minus 2b minus 2c. Then here we have to add this one. 1 plus 0, 1. A cancel. 3b minus 2b, b. And 3c minus 2c plus c. So this is another equation. Equation number 4. Here already equation number 1 is there. From 1 and 4. What is here? 0 is equals to minus b plus c, and this is what? 1 is equals to b plus c. In this case, what we get here? 0, 1, that is 1, is equals to here minus b plus b cancel. C plus c, 2c. Therefore 1 is equals to 2c, then c is equals to 1 by 2. C is equals to what? 1 by 2 we will get. So already here 0 is equals to b plus c there from equation number 1. From 1. 0 minus b c plus c. What is 0 is equals to minus b plus of. Then what do you get? Minus b is equals to minus of. Then b is equals to 1 by 2. So we got the values of b and c. Now we can substitute the values of c and b in any of these two equations. You will get the option. You can substitute the equation number 2 or 3. We will get the answer A. So 1 is equals to here. I am going to substitute in the equation number 2. 1 is equals to A plus 3b. B value is what? 1 by 2. 3 by 2 plus, and c value is what? 3c, 3 into 1 by 2, 3 into 1 by 2 will get. That means what? 1 is equals to a plus 3 by 2 plus 3 by 2. That is what? Nothing but 3. So then a is equals to what? 1 minus 3. A is equals to what? 1 minus 3. Then a is equals to minus 2. A is equals to minus 2. Very simple. 3 by 2 plus 3 by 2. 2 3 by 2. 2 to cancel. What do you get? 3 only we got. 1 is equals to a plus 3. Then a is equals to 1 minus 3. Then a is equals to minus 2. A is equals to minus 2. Now we can substitute the values of a, b, c in this equation. So let's check. We will get the option or not now. So I need some space. That's why here I am erasing this one. So please wait for some time. To get anything, you have to must be patient. We have much patience. Okay. So now here I am going to write L is equals to c to the power of a. C to the power of a. A means what? Minus 2. A is what? Minus 2. And g to the power of b. B value is what? 1 by 2. B value is what? 1 by 2. And e square 4 pi epsilon naught whole to the power of c value what is? 1 by 2. 1 by 2. So that's why here simply from the equation c to the power of minus 2 means what? We will write L is equals to 1 by c square. L is equals to 1 by c square into, and this should be written as here g of e square by 4 pi epsilon naught whole to the power of 1 by 2. So that is the equation for dimension in the equation for length in the dimensions of c, g and e square by 4 pi epsilon naught. So now we can check the answer in the among the 4 options. 4 options is there. Here simply the fourth one is right one. 1 by c square into g into e square by 4 pi epsilon naught whole to the power of 1 by 2. That's why children, option D is the correct one. This is the right one. Clear? See the next question. It was given in NEET 2016. The question should be like this. Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are 3 fundamental constants. Which of the following combinations of these has the dimension of length? Dimension of length. So he was given some 3 fundamental quantities. So one is the Planck's constant, and next one is the speed of light, and next one is gravitational constant. These 3 should be taken as the fundamental constants for length. So if you can take them like that, then the combination should be like this. Among the four one, which is the right one, we have to find out. First option is root hc by c to the power of 3 by 2, and second option is root hc by c to the power of 5 by 2, and third option, C option, under root of hc by g, and under root of gc by h to the power of 3 by 2. So that is the, here we have 4 options. Now again we have to follow the same principle of homogeneity and dimensional equation concept. Here first thing is Planck's constant. What is the Planck's constant? Here dimension formula is there, that is we have to know. H is equals to m L square T inverse 1. It is the dimension formula of Planck's constant. Let's check here. E is equals to h nu. H is what? E by nu. What is E? Energy. M L square T inverse 2 by nu is what? Frequency. T inverse 1. Then what, right? M L square T to the power of minus 2 and T to the power of 1. Then what you get? M L square T inverse 1. It is the dimension formula of here Planck's constant. So that's why whatever that is the right one. And next one is here. What is capital G? Universal gravitational constant. That is the here M inverse 1 L cube T inverse 2, and C is what? Speed of light. That is what? LT inverse 1. So these 3 are given. So again same concept, I am going to take L is proportional to, the first thing you have to follow the given order. First thing is first quantity, what is Planck's constant. That's why you can write h to the power of a. And what is second fundamental quantity? Vacuum. So that is speed of light in vacuum. That is what? C to the power of b. And now third one is what? Gravitational constant G. That's what, right? G to the power of C. G to the power of C, like that. You can take dimension A, B, C or X, Y, Z, any whatever may be. Sometimes some textbooks they will give A, B, C. Some textbooks in like X, Y, Z, like that also. So here some constant, we have to use some constant in the quadrant. L is equals to H to the power of A into C to the power of B into G to the power of C. Here what is L? Length. The dimension formula is what? Capital L. And this H. What is H? Planck's constant. M L square T inverse 1 whole to the power of A. And what is C? Velocity of light. L T inverse 1 whole to the power of B. And G is what? M inverse 1 L cube T inverse 2 whole to the power of C. So again same thing, according to the principle of homogeneity, the physical quantity which is in the dimensional equation that should be have same dimensions on both sides, like LHS and RHS. By using that, we are comparing the first we have to compare the dimensions of M on both sides. On LHS there is no, we can write simply it is like M to the power of 0 L and T to the power of 0 we can write. Length how we can write? M to the power of 0 L to the power of L T to the power of 0. That's why here on LHS dimension of L is what? 0. And now it is what? M to the power of 1 into A and 0 here, plus M to the minus 1 into C, minus 1 into C, so minus C. Then what it is? 0 is equals to A minus C. This is equation number 1. Now in the same manner we have to compare the dimensions of L. Here L to the power of 1 is there, 1 is equals to here 2 into A, 2A, and 1 into B plus B. L to the power of 1 is there, 1 into B. Again 3 into C plus 3 into C. This is equation number 2 now. And now we have to compare the dimensions of T on both sides. Here to the power of 0 it is there, 0 is equals to here minus A, minus 1 into A, minus A, plus minus 1 into B, minus B, and minus 2 into C, minus 2C. This is equation number 3 now. Now we have to solve these three equations, then we will get the ABC values. For that, now I am going to add the 2 plus 3 first. So 1 is equals to 2A plus B plus 3C, and 0 is equals to minus A minus B minus 2C. You can add them now. 1 plus 0, 1. That is equals to 2A minus A, B cancel. 3C minus 2C, yes, what is? C is there. Therefore 1 is equals to A minus C, the equation number 4. Clear? So here we have to substitute the values. Now here you can take the equation number 1 and 4 now. From equations 1 and 4. What is equation number 1? 0 is equals to A minus C. And this is what? 1 is equals to A minus C. A is equal. Here what is? This is 3C minus 2C. That is what? Plus C. 3C minus 2C what? Plus C. Therefore write 1 is equals to A plus C. 1 is equals to A plus C. Then what you get here? CC cancel. A plus A. 2A. 2A is equals to 1. That means A is equals to 1 by 2. A is equals to 1 by 2. That is the first value here. And next thing is what we know? 0 is equals to A minus C. 0 is equals to A minus C. Then A is equals to what? C. So already what we got A value? Here 0 is equals to A minus C is there. From equation 1, that what you are right? A is equals to C. Already what you got the value for A? 1 by 2. That's why here C also 1 by 2. So now we have to find out the value of B. For that you can take any one of the equation. I am going to take equation number, this is what? 2. 1 is equals to 2A plus B plus 3C. Clear? So 1 is equals to here 2 into A value is off plus B into 3 off. Clear? So what do you know here? 1 is equals to 2 to cancel here, 1 plus B plus 3 by 2. That means what? 1 is equals to 1 plus 3 by 2 plus B. Do LCM here. 2 plus 3 by 2 plus b. Therefore 1 is equals to 5 by 2 we will get. So we need some space. That's why here I am going to erase. One is equals to 1 plus 3 by 2 plus b. Here 2 LCM 2 plus 3 by 2 plus b. So what do you get? 1 is equals to 5 by 2 plus b. Then b is equals to what? 1 minus 5 by 2. 1 minus 5 by 2, what do you get? It is simply here now. B is equals to 2 minus 5 by 2. That means what we got? B is equals to minus 3 by 2 we got. So B is equals to minus 3 by 2. So A is equals to 1 by 2 and C is equals to 1 by 2 and B is the minus 3 by 2. Minus 3 by 2 we got. So now substitute the values A, B, C in the primary equation what we assumed. This is the primary equation here. So then this is the equation what we are taking here. So L is equals to h to the power of A. That means h to the power of 1 by 2 and c to the power of b. What is b? Minus 3 by 2. And what is g? G to the power of c is there. That means what? 1 by 2. 1 by 2 we have. Therefore what, right? L is equals to, we will write hg whole to the power of 1 by 2 by, we can write c to the power of 3 by 2. C to the power of 3 by 2. That means what we write here? Under root of hg by c to the power of 3 by 2. That is the equation for length in terms of h, g and c. That's why here among the four options, option A is the correct one. Under root of hc by under hc, I think so it is sorry, this is hg. Okay, under hc by c to the power of 3 by 2. A option is the right one. So this is hg na. So hc by, so option is the correct one. See the next question. It was given in 2015 NEET. Question should be like this. If dimensions of critical velocity Vc of a liquid flowing through a tube are expressed as neta to the power of x, p to rho to the power of y, r to the power of z, where n neta is the coefficient of viscosity and rho is the density of liquid and r is the radius. Clear? So neta is what? Coefficient of viscosity, rho is the density and r is the radius of the pipe respectively. Then the values of x, y, z are. So options are given. First option minus 1, minus 1, minus 1. B 1, 1, 1. Third option 1, minus 1, minus 1. D minus 1, minus 1, 1. So you are simply given that there is one pipette is there, in that fluid is going. Then the critical velocity is given by the term Vc. That should be expressed in terms of neta to the power of x. So we are going to write Vc is proportional to neta to the power of x and rho to the power of y and r to the power of z. So it should be like this. So now we want to find out the values of x, y, z. That is the topic here. Again we have to use the same concept of dimensional equations and principle of homogeneity. So first thing is here, what is neta here? Coefficient of viscosity, and that should be given by the formula like this, delta V by delta X. So here F by A, what is pressure? So M L T inverse 2 by L square. Then what do you get? M L inverse 1 T inverse 2. Clear? So M L inverse 1 and T inverse 2 by delta V by delta X. What is velocity gradient? LT inverse 1 by L. That is what? T inverse. T inverse. That's what you have right here. T inverse. Then what do you have right? M L inverse 1, T inverse 2 and T to the power of 1. Then what do you get? m L inverse 1 P inverse 1. That is the dimension formula of coefficient of viscosity. Clear? And next thing is what it is? Rho. What is rho? Density was given. Mass for volume m L to the power of minus 3. And what is given? R is the radius. So R is equals to L. And what is we see? Critical velocity or velocity. That is what dimension formula? LT inverse 1. Now we have to substitute all these dimensional formulas in that one. Some constant into Vc is equals to eta to the power of x, rho to the power of y, and r to the power of z. Here not giving any priority to the constant, because for constant there is no dimensional formula. So here Vc means what? L T inverse 1. That is equals to eta is what? M L inverse 1 P inverse 1 whole to the power of x, and rho m L inverse 3 whole to the power of y. And again, what is r? R is the radius. R is the radius. That's why here simply we have write L to the power of z. L to the power of z. So again here we have to compare the dimensions of same physical quantity on both sides according to the principle of homogeneity. So here first we have to compare the dimensions of m on LHS and RHS. Here simply nothing is there, means what? M to the power of 0 is there here. That's why here 0 is equals to here m to the power of 1 into x, x, m to the power of 1 into y, x plus y, and there is no m. That's why here simply what? Write 0. So 0 is equals to x plus y. It is equation number 1 when we compare the dimensions of m on both sides. And now here L, we have to compare the dimensions in that equation on both sides. Here 1 is there. 1 is equals to minus x, minus 3 into y, minus 3y, and z plus z is the equation number 2 now. And similarly now here we have to compare the dimension of t on both sides. Then what you get here? Minus 1. To the power of minus 1 is there here. Minus 1 into x, minus x, and it is what? 0. To the power of minus 1, here 0, here 0. Then what you get? 1 is equals to x. 1 is equals to x here. Clear? So this is the third equation. Already in the first equation what you have? 0 is equal to x plus y. Here already x value is 1. Then y value is what? So here 0 is equals to x plus y is there, and 0 is equals to 1 plus y, and y is equals to minus 1. Y is equals to minus 1. Already we got x value and y value. Now we have to get the z value by using the equation number 2. So substitute the values of x and y in equation number 3. 1 is equals to what? 1 is equals to minus x minus 3y plus z. The 1 is equals to x value is what? Minus 1. 3 into y value is what? Minus 1 plus z. Then 1 is equals to here minus 1. 3 into minus 1 means what? Plus 3 plus z. So it is, don't confuse here, this is the z, not 2. So 3 minus 1, 2. 1 is equals to 2 plus z, and z is equals to what? 1 minus 2. Then z is equals to minus 1. Z is equals to minus 1. So observe here, x is equals to 1, y is equals to minus 1, z is equals to minus 1. So we have to check the options. Third option is the correct one. Why? Because 1, minus 1, minus 1. So third option is the correct one. See the next question. It was given in 2014 NEET exam. If force F, velocity V, and time T are taken as fundamental units, then the dimensions of mass are. We have to express the mass in terms of force, velocity, and time by using dimensional analysis. Some options are given. First option is FV T inverse 1. Second option FV T inverse 2. Third option FV inverse 1 T inverse 1. And fourth option FV inverse 1 T. So Again, by using the same dimension analysis, we have to do this one. First thing is what you have to take, M is proportional to F, V and T. Again, what you have to take here, dimensions are A, B and C. So first thing is what is mass, dimension formula capital M. Clear. And what is F? He was given, F is the force, the dimension formula is M L T inverse 2. And what is V? V is the velocity, L T inverse 1. Okay. And what is T? Time. T is the time, its dimension formula also T. So here now we have to use some constant, F2 for A and V2 for B and D2 for C. Again we have to substitute the dimensions formulas, M L T inverse 2 old for A, and V is the velocity, L T inverse 1 old for B, and T is the time old for C. Again we have to use the dimension analysis by using the principle of homogeneity. According to the principle of homogeneity, the dimension and the physical quantities which are in the dimensional equation that we have same dimensions on both sides. That is the formula. Here first we have to compare the dimensions of M on both sides. That is what here 1 it is there, and here M2 for 1 into A, and here it is, no it is there 0 and 0. Therefore A is equals to 1. This is equation number 1. Now compare the dimensions of L on both sides. L, nothing is there here, 0. Here 1 into A, 1 into B. So again nothing is there. Here 0 is equals to A plus B, A value is 1, and 1 plus B is equals to 0, then B is equals to minus 1. Equation number 2 now. And similarly we have to compare the dimensions of T on both sides. Again nothing is there here, 0 is equals to minus 2A minus B, minus 1 into B minus B, 1 into C plus C. Therefore this is the equation number 3 now. Here now we have to substitute the A value, B value in that equation, we will get the C value. Clear? So 0 is equals to minus 2A minus B plus C. Clear? So 0 is equals to minus 2 into A value is what? 1, and B value is what? Minus 1. B value is what? Minus 1. We have to substitute. Here minus of minus 1 plus C. Then 0 is equals to what? Minus 2, minus of minus plus. Then here minus 2 plus 1 means what? Minus 1 plus C is equals to 0. Then C is equals to 1. C is equals to 1 here. Now substitute those values there. Here what it is? M is equals to F2 power of A means what? 1, and V2 power of minus 1 and T2 power of 1. So therefore F V inverse 1 and T. So this is the dimensional formula of mass in terms of force, velocity and time. So check the options now. This is the wrong, and this is the wrong, and this is the wrong. F, V minus 1 and T. So fourth option is the right one. D is the right one. See the next question. It was given in the mains 2011. The density of a material in CGS system of units is 4 gram per centimeter cube. 4 gram per centimeter cube. In a system of units in which units of length is 10 centimeters and units of mass is 100 grams, the value of density of material will be. Clear? Already one system is there. In that what we got density 4 gram per centimeter cube. If we can take the system, if it is what it is, length in 10 centimeters and mass is 100 grams, then the value of density of material will be what? That is the question here. Options are given 0.04, 0.4, 40 and 400 children. So very simple here. We have one formula is there. N is proportional to 1 by u. N is proportional to 1 by u. It is there. From that what it N1 U1 is equals to N2 U2. So N1 U1. In the first system what it is here, N1 value is 4 and units are what? Gram per centimeter cube. Clear? And now we want to find out the N2 value. Here in this case 1 gram should be taken as how much? 100 grams. 100 grams by centimeter. 1 centimeter equals what here? How many? 10 centimeters. That means what? 10 cube we have. Clear? So then for 4 is equals to what right here now? Again gram per centimeter cube we have. Both should be cancelled. 4 is equals to N2 into 100 by 10 cube means what? 10 square into 10 we can write. These two are cancelled. 4 is equals to N2 by 10 and N2 is equals to what? 4 into 10. And the value is what? 4 into 10. So we can take gram per centimeter cube like this. So here C value is the right answer. See the next question. It was given in 2006 and very easy one and very logical one. The question is the velocity V. The velocity V of a particle at time t is given by V is equals to AT plus B by T plus C. V is equals to AT plus B by T plus C, where A, B and C are the constants. The dimensions of A, B and C are. So velocity is given by that particular relation. In that A, B, C are the constants. Now for that constants we have to write the dimensional formulas. Okay. Options are given L, LT, LD inverse 2, LD inverse 2, L, T, L square, T, LD inverse 2, LT inverse 2, LT and L. So here now we know the principle of homogeneity. We know the principle of homogeneity. If any relation like this x is equals to y plus z, it means that we can add the physical quantities which are having the same dimensional formula. That means here y and z we are added together means what? Both are having the same dimensions. And dimensions of here x should be equals to y and x should be equals to z also. Clear? That's why here you have to remember that the first thing is we can add the physical quantities which are having the same dimensional formulas. Clear? So first thing is here V is equals to AT plus B by T plus C. Clear? Now V is equals to AT plus B by T plus C. In this case we can write V is equals to AT. Why? Because the dimensions of V should be same as AT. That's why already what is V? LT inverse 1 and that should be is A into T means what? Time. Then what, right? A is equals to LT inverse 1 by T. That means LT inverse 1 and T inverse 1. Then what do you get? LT inverse 2. So this is the dimension formula of here A. And now in this equation you can observe T plus C is there. T plus C is there. Clear? So T should be added to the C. That means T should be have same dimension formula as time. Therefore C is equals to T. Clear? And now here we can write third one. What is V is equals to now B by T we can write. We will write B by T we can write. So then what, write V into T is equals to B. Now what is V? LT inverse 1. And what is small t? Cap time. That's what, write T. Now what do you get here? T to the power of minus 1 and T to the power of 1. That means what? L to the power of 0 will get. That is B. The B means what is L. So that's why here the dimension formula of A, B, C are. For A what you have? LT inverse 2 is there. For B, L is there. And time C is what? Time T. So that's why we have to check the options. What do you have? LT inverse 2, LT. LT inverse 2, L and T. That's why option B is the correct one. See the next question. It was given in 1996. The question is like this: an equation P plus A by V square is equals to B into theta by V, where P is the pressure, V is the volume, and theta is the absolute temperature. If A and B are constants, then the dimensions of A was asked. Clear? So same thing here, we are going to use the principle of homogeneity. The physical quantities which have same dimension formulas, they can be added together. That's why here P is added to the A by V square. It means that the dimensions of P should be same as A by V square. So both are having the same dimensional formulas. That's why here, what is P here? Pressure. P is equals to force per area. Then what you get? M L T inverse 2 by area is L square. Then P is equals what? M L inverse 2 T inverse 2. Then what you get? P is equals to L to the power of 1 minus 2 T inverse 2. Then P is equals to M L inverse 1 T inverse 2. This is the dimension formula we are going to use. And what is V? V is the volume. So for volume dimension formula is what? L cube. Therefore what right here? P into V square is equals to A now. P is what? M L inverse 1 T inverse 2 of V square. What is V? L cube. And it is whole square is equals to A. Then M L to the power of minus 1 T to the power of minus 2 L to the power of 6. So then what right? M into L to the power of minus 1 plus 6 T to the power of minus 2 we have. That is equals to what we have? A. That means what it is? A is equals to M into 6 minus 1, 5. L to the power of 5 T to the power of minus 2. So this is the dimension formula for constant A. What is? M L to the power of 5 T to the power of minus 2. Therefore C option is the correct one. Which of the following? See the next question. It was given in 1995. Very easy and direct bit. Which of the following is a dimensional constant? So among the four options, he was four all are constants. In that, which is having the dimensional formulas? That is the question here. So first one is relative density, second one is gravitational constant, third one is refractive index, and fourth one is Poisson's ratio. So Poisson's ratio, what it is? Sigma is equals to lateral strain by longitudinal strain. So it is the ratio. That's why for this there is no dimensional formula. And refractive index also same thing. Mu is equals to C by V, or mu is equals to sin I by sin R. Mu is equals to C by V. It is there. C is the velocity and V also velocity. That's why both are cancelled together. There is no dimensional formula and no units. And relative density of the substance by density of another substance. That's why that is also ratio. That's why these three are the constants. They do not have any dimensional formulas. The only one thing is gravitational constant has dimensional formula. That is what? G is equals to m-1 L cube T inverse 2. This is the dimensional formula of G. So that's why second option is the right one. See the next question. It was given in 1993. Turpentine is flowing through a tube of length L and radius R. The pressure difference between the two ends of the tube is P. The viscosity of oil is given by the relation NEET is equals to P into R square minus X square by 4VL, where V is the velocity of oil at a distance X from the axis of the tube. The dimensions of NEET are. So children, according to the given problem, there is one pipette tube is there that should be having some length L and radius is R, and the pressure difference between the two ends is here. This is the one end, this is the another end. That is should be having pressure difference is what it is P, and V is the velocity of the oil at a distance x from the axis of the tube. So what he was given, velocity is the V. So simply in that problem he was given one relation, what it is, neta is equals to P of R square minus x square by 4VL. So by using this equation we have to find out the what? Dimensions of neta. Dimensions of neta. What is neta? Coefficient of viscosity. So here options are given m to the power of 0, L to the power of 0, T to the power of 0. And option B is m L T inverse 1. Third option is m L square T inverse 2. And fourth option is m L inverse 1 T inverse 1. That's why here you have to take what is P. P is the pressure. P is the pressure. M L inverse 1 T inverse 2. You can check it like this also. F by A, force M L T inverse 2 by L square. Then what you get? M L inverse 1 T inverse 2. And what was given? V is the velocity was given. L T inverse 1. And what is L? L is the length. And here R square minus x square. So here we are writing simply according to dimensional formula, according to the principle of homogeneity. R and x both are having the same dimensional formula because both are involved in the same arithmetic operation. That's why here simply we have to write neta is equals to P. What is P here? Pressure M L inverse 1 T inverse 2 into here what is R square minus x square. That means simply here we will write this is L square by 4 is constant, V is what? Velocity, L T inverse 1 and L is the length. Clear? Then what we get? Neta is equals to M L inverse 1 T inverse 2. This is L square and this is also L square. So both should be here cancelled together. And this is what? T to the power of minus 1. Then now is what we get here? M L inverse 1 T inverse 2 by here. What we know? T inverse 1 is there. Then what do you get here? M L inverse 1 T inverse 2 and this comes to the numerator what, right? T. Then what do you get? M L inverse 1 T inverse 1. So this is the dimension formula for coefficient of viscosity. So among the four options, option D is the right one. See the next question. It was given in the year 1990. Very easy question. The frequency of vibration of a mass suspended from a spring constant K is given by relation F is equals to A into m to the power of x k to the power of y, where A is the dimensionless constant. The value of x and y are here there is one spring, it is there. For that spring some mass is attached. Thus we have a spring constant how much? K. The frequency of vibration is how much? F of a mass suspended from a spring constant K is given by relation F is equals to A into m to the power of x and k to the power of y. What is A? A is the constant there and m is the mass and k is what? Spring constant. Then what you have to find out? We have to find out the dimensions of now values of x and y. X and y. Clear? Option A is given x is equals to 1 by 2, y is equals to 1 by 2. B is x is minus 1 by 2, y is equals to minus 1 by 2. And C is what? Off minus off. D is minus off and off. So that is the problem, children. Here again we have to use the dimensional analysis and principle of homogeneity. Here what is F? Frequency. For frequency dimension formula is what? P inverse 1. Clear? And what is M? Mass. Its dimension formula is capital M. And what is K? K is the spring constant. Force per length. Then what you have? M L T inverse 2 by L. Then what you get? M T inverse 2 we have. Clear? Substitute here now. F is what? T inverse, that is equals to a dimensionless quantity, and M is what? M to the power of x, and K is what? M to the power of minus 2. M to the power of minus 2 it is there. Clear? So again what we know, according to the principle of homogeneity, in a dimensional equation, the physical quantity must have same dimensions on both sides. That's why we have to compare the dimensions of all the quantities in LHS side and RHS. So first we can go for mass. This side mass is not there. That's why here what right? 0 is equals to x. 0 is equals to x. Here what is? This is the y. So 0 and x plus y. This is equation number 1. And similarly we can compare now dimensions of L. So here L is not there, here also not there. And third one, compare dimensions of T. What is minus 1 is equals to minus 2y. Minus 1 is equals to minus 2y. Minus minus cancel. 1 is equals to 2y. And y is equals to what? 1 by 2. Y is what? 1 by 2. Now we have to substitute the value of 1 by 2 in that equation. What is here? 0 is equals to x plus y and x plus 1 by 2. Then x is what? Minus 1 by 2. So x is the minus 1 by 2 and y is the y by 2. So y is the 1 by 2. So given options you have to check it. X is equals to, here there are two options with the negative values of x. X is minus 1 by 2, x is minus 1 by 2. Here y is the minus 1 by 2, here y is 1 by 2. So no need to confuse here. So here D is the right answer. See the next question. It was given in 1993. Very easy one. The time dependence of physical quantity P is given by. The time dependence of physical quantity P is given by. P is equals to P naught exponential of A minus T square, where A is constant and T is the time. The constant A. The constant A. Options are given. A is dimensionless and A has dimensions T to the power of minus 2. A has dimensions T inverse T square. A has dimensions of P. So that is the simply about the question. And the given expression is what? P is equals to P naught into exponential of minus A T square. Clear? So in this case P and P naught both are having the same dimension formulas, and the thing what it is written in the exponential, that should be dimensionless. That should be dimensionless. That's why A into T square is the dimensionless, or simply you can take it is a constant. It is a constant. So then AT square is equals to constant, means that's simply what right here. A is equals to 1 by T square. A is equals to 1 by T square or K by T square, whatever may be. We are using the constant. You can write like this also, K by T square. What is K here? Constant. So for constant there is no dimensional formula. That's why what I write here, A is equals to 1 by T square. A is equals to 1 by T square. What is the small t here? Time. Time dimension formula is capital T. That means here what is? A is equals to what, right? T to the power of minus 2. Therefore A has dimensions that should be equals to the T to the power of minus 2. That's why B is the right one. See the next question. It was asked in the 1989. If x is equals to AD plus BT square. If x is equals to AD plus BT square, where x is the distance travelled by the body in kilometers, while t is the time in seconds, then the unit of B is options kilometer per second, kilometer per second square, kilometer into second square. Clear? So what he was given? He was given one equation. What it is that? X is equals to AT plus BT square. Clear? And what he was saying? X is in kilometers, distance is in kilometers, and time is in seconds. Then what you have to find out? Units of B. Units of B. So dear students, according to the principle of homogeneity, we can add the same, which are having the same dimensional formulas. At the same time, in LHS, RHS both are having the same dimensional formula. That's why I write x is equals to BT square we can write. And B is equals to what? x by t square we can write. X by t square we can write. X is what? Distance. That should be measured in terms of kilometer. Time is second. That's why we have write kilometer per second square is the unit of B. That's why here third option is the correct one. See the next question. It was given in 1999. The dimension formula of magnetic flux. Dimension formula of magnetic flux is. So we want to find out the magnetic flux dimension formula. Some options are given. First option is m to the power of 0, l to the power of minus 2, t to the power of minus 2, a inverse 2. M2, m l to the power of 0, t to the power of minus 2, a inverse 2. And third option, m l square, t inverse 2, a inverse 1. And D option, m l square, t inverse 1, a cube. Clear? So, as usual, magnetic flux formula is what? Pi is equals to B into A. What is B? Magnetic field or induction? Magnetic field induction, and A is the area. So we know the formula F is equals to IBL. From that what right? B is equals to F by IL. So what is F? Force. ML T inverse 2 by I means current. L means L. L going to be cancelled. Then what do you have right? M T inverse 2 A inverse 1. That is the formula for what? Magnetic induction. And now flux is what? Pi is equals to B into A. M T inverse 2 A inverse 1. A is what? Area. L square we can write. Therefore pi is equals to M L square T inverse 2 A inverse 1. So this is the dimension formula of magnetic flux. So among the options you have to check it. Which is the right one? M L square T inverse 2 A inverse 1. So option C is the correct one. See the next question. It was given in the year 1991. The dimension formula of permeability of free space mu naught is. So we want to find out the dimension formula of mu naught. So given options are there. 4 options are given. M L T inverse 2 A inverse 2, M L inverse 1 T, M to the power of 0 L square T inverse 1 A square, and none of these. So among the 4, one is the right one. We have to select that one. So permeability formula is like this. We can write F is equals to mu naught by 4 pi into M1 M2 by R square. Then what you get here? Mu naught is equals to F into R square. F into R square by M1 M2. So 4 pi is constant. That's why no need to write that one. So mu naught is equals to F is what? Force. M L T inverse 2. And R is what? Length. L square by here M1 M2 force length should be written as LA into, you can write LA like this. Then 48 mu naught is equals to here M L T inverse 2 L square L square both should be cancelled. What you get here? A square. Then what you get? M L to the power of minus 2 A inverse 2. So this is the dimension formula for mu naught. So children, this is the one way to find out the dimension formula of mu naught, and there is another one. It is there. dV is equals to mu naught by 4 pi into ideal sin theta by R square. So sin theta is the angle. There is no dimension formula for it. Then what right? Mu naught is equals to dV into R square by I into dl. So dB, just now we discussed what it is. dB means what? MT inverse 2 A inverse 1. What is MT inverse 2 A inverse 1. And R means what? Distance square L. And I means what? Ampere current. dl means what? Length. But what is L? Therefore what you get here? M L square and L to the power of minus 1 and A inverse 1 and A inverse 1 to T inverse 2. Then what we get? M L T inverse 2 A inverse 2. So this is another way to find out the dimension formula of mu naught. So both are same, m l t equals to a equals to m l t equals to a equals to. So you can use any formula of this one. So among the options, so first one is the right one, m l t equals to a equals to. See the next question, it was given in 1990. According to Newton, the viscous force acting between liquid layers of area A and velocity gradient area A and velocity gradient delta V by delta Z is given by F is equals to minus neta into A into delta V by delta Z, where neta is constant called coefficient of viscosity. The dimension formula of neta is, according to Newton's, the viscous force between the acting between liquid layers of area A and velocity gradient is given by the equation F. Okay, so one fluid is there, some pipette is there, in that some fluid is there. There is some frictional force acting between the layers of the fluid, that is what we call viscous force. That should be given by the formula F is equals to minus neta into A into delta V by delta X. That is the formula for viscous force, the force acting between the layers of a fluid. That should be what we call viscous force. And simply what you have to find out now, coefficient of viscosity we have to find out. Neta is equals to what, right? F by A by delta V by delta Z. Clear? What is F here? Force. Dimension formula is ml t equals to. And what is A? Area, L square. And what is delta V by delta X? Velocity gradient. So velocity by distance, that is what? T inverse 1. T inverse 1. Clear? Substitute now. Theta is equals to force m l t inverse 2 by L square by delta V delta X. How much you got? T inverse 1 we got. Then what, right? m l to the power of minus 2, t to the power of minus 2 and t. Then what you get? m 1 minus 2 minus 2 plus 1. Then what you get? m l to the power of minus 1, t to the power of minus 1. So this is the dimension formula of coefficient of viscosity. Now option D is the right one. See the next question. It was given in 1989. The dimension formula of self-inductance. Dimension formula of self-inductance is. So some options are given here. Let's check here. Self-inductance, pi is proportional to I and pi is equals to L into I and L is equals to pi by I. Clear? So what is pi? Flux. What is L? Self-inductance. What is I? Current. And again what, right? Pi is equals what you are, right? B into A. Again B is equals what, right? Simply F is equals to IBL and B is equals to F by IL. So these are the formulas we are going to use now. So B is equals to M L T inverse 2 by current A, length L. Then what you get? B is equals to L is going to be cancelled. T inverse 2, A inverse 1. Clear? Then what is flux here? Pi is flux. Pi is equals to B into A. Pi is equals to B means what? M T inverse 2, A inverse 1. A is what? Area, L square. Then what are here? M L square, T inverse 2, A inverse 1. And here again what is current? L is equals to pi by I. So M L square, T inverse 2, A inverse 1 by current again A. Then what you get here? M L square, T inverse 2, A inverse 2. So this is the dimension formula of self-inductance. So among the four options, C is the right one. M L square, T inverse 2, A inverse 2. See the next question. It was given in the year 1989. Very simple question, I think so, very easy for you. The dimension formula of torque is, so four options given. In that we have to select one, any correct one. What is mean by torque? tau is equals to r, because F very simple, force into distance. F is what? Force. Its dimension formula is what? M. A is what? Acceleration, M L T inverse 2. And R is what? Position vector, distance L. Therefore tau is equals to what? L and M L T inverse 2. L M of L to the power 1 plus 1 and to the power of minus 2. Then what you get? M L square T inverse 2. So this is the dimension formula of torque. That's why here option A is the correct one. See the next question. It was given in the year 1988. If C and R denotes capacitance and resistance, the dimension formula of CR, the dimension formula of CR is, what is C? Capacitance. What is R? Resistance. Then the dimension formula of CR is what? That is the question. Here some options are given, and the fourth option is given, not expressible in terms of MLT. But what you can think, actually it was given only because of to confuse us only. Why? Because here that should be expressed in terms of MLT. Clear? So generally what you can think, C and R belongs to current, that's why we can give the choice for D, but it's not correct. So let's see here, what is C and R? C is the capacitance, Q by V we can write. Again, what is V? W by Q. Substitute now, Q by W by Q. Then means what? C is equals to Q square by W. And again what we write? Q is equals to IT we can write. Then C is equals to IT whole square by W. That means what? C is equals to I square T square by W. That is the one thing. And now what is R? Resistance. V is, according to Ohm's law, right? V is equals to IR. R is equals to V by I we can write. Again what is V? W by Q we can write. V is equals to W by Q by I. That means R is equals to what? W by IT into I. Q is equals to I. Therefore R is equals to what? W by I square into T. W is equals to, R is equals to W by I square into T. Now what we have to find out? We want to find out the CR. CR. Give some space there. CR is equals to, what is the value? I square T square by W into W by I square into T. So I square cancel, W cancel. What do you have? CR is equals to T square by T is there. That means what? CR is equals to T square by T is there. That means what? CR is equals to T. CR is equals to what? T. Therefore CR is equals to T is the time. That's what, right? CR is the dimension formula is T. It means that what you have to write? M to the power of 0, L to the power of 0, T to the power of 1. So that is the dimension formula of product of C and R. C and R. That's why A option is the correct one. See the next question. It was given in the year 1988. Very easy one. The dimension formula of angular momentum is, the dimension formula of angular momentum. Options are given: ml square d inverse 2, ml inverse 2, d inverse 1, ml d inverse 1, ml square d inverse 1. So 4 options are given. In that we have to find out the one is the right one. So angular momentum, L is equals to what, right? mv/r we can write. L is what? Angular momentum. M means what? Mass. That should we have dimension formula is capital M. And V is what? Velocity. LT inverse 1. And what is R? Distance. Dimension formula is what? L. Substitute L is equals to M of here LT inverse 1 and L. So then what, write? M L to the power of 1, L to the power of 1, T to the power of minus 1. Then what you get? M L to the power of 1 plus 1, T to the power of minus 1. Then what you get? M L square T inverse 1. That is dimension formula of angular momentum. M is formula of angular momentum. So among the four options, D option is the correct one. So dear students, this is enough for this video. So dear students, if you can understand my way of explanation, if my content will reaches to you, then please subscribe my channel, like, share, comment the video. So if you want to get the more videos from my side, you have to support me and you have to suggest our channel to who required it. Okay, thank you for watching.